Good afternoon, everybody. This is Mark Osborne, the Senior News Editor with PV Tech. Well, welcome, everybody. We're just about to begin now with this very interesting topic. I wanted to introduce you to Dr. Etienne Menard, who's the co-founder and CTO of HeliosLite. This is a discussion about their new technology, highly disruptive from their perspective on as a 1.5 axis tracking system. We also have with us Daniel Zywietz, who's the founder and CEO of Enerwhere, and these are developers in the Middle East and work with O&M, and he'll be discussing their involvement with this. Obviously, many people are aware that the tracker, especially single axis trackers, have gone through quite a transformation in technology development curves over the last couple of years, all of this driven by LCOE. We've also seen developments further upstream with bifacial modules and the rapid development of tracking systems to best enhance or take advantage of the yield improvements from bifacial. So what's very exciting here is that this is a real-world analysis of HeliosLite's 1.5 axis tracker, and obviously this is in hot climates, this is desert conditions, and the way in which the technology works, I think, opens up a lot of possibilities for project developers around the world. So with that, Dr. Menard, it's over to you.
All right, thanks a lot, Mark, for the introduction. Before we go into technology, I'd like maybe to say a few words about our company, and we'll actually first start with a poll question. So it's actually back to you, Mark.
Yeah, we'd just like to take a quick poll here regarding as you'll see on your screen, it says in today's market, there are two most probable factors to improve a PV project's return on investment. You can select and click on as many of these components here as you wish. Obviously, the first one there is lower investment cost of components. The second is the higher efficiency of PV modules. Also higher energy output, PV tracking devices, and then lower O&M costs. And we finish there with higher value-added projects, and this includes obviously off-grid, things like hybrid systems as well. So we'll just take a pause just to let people click on those just as a quick poll that we'd like to start with. All right, well, we can already share these results. That was quite quick. Now here we have 65%, I'm not surprised at this myself, 65% say it's lower investment costs of components. This also includes, which is interesting actually, the high efficiency of PV modules is also a score of 65%. Higher energy output, PV tracking devices, and again, I'm interested in this, is at 50%. Lower O&M costs only comes in at 33%. And the lower level one at 8% is higher value-added projects. That's very interesting.
Okay, thanks a lot for your answer to this first poll question. So obviously, in this presentation, we'll put focus on tracking system. But before we go into technology, I'd like maybe to give you a few words on HeliosLite, since we're basically a late-stage startup company founded in 2013. And we are basically a technology company. So we focus on developing products and services. And we basically don't have in-house manufacturing capability. We're relying on partners to manufacture our product. And so internally, we focus on doing the design for our product in terms of mechanics, electronics, and we do all the software development to be able to do basically remote diagnostic and monitoring of the system that we deploy in the field. And so in terms of services, we obviously market our product, and we partner with manufacturing company to be able to provide either global or local supply capability, because we'd like, when we can, in some countries to offer local content if possible, and trackers are actually a very good product for that because all the metal can be easily sourced locally. And of course, we provide installation training and commissioning to be able to help developers which are using our product to be able to commission themselves their installation. And from our office, with our monitoring system, we can do diagnostic of the system in the field, and we can do remotely, for example, software upgrades and things like that. And of course, depending on project, we can tailor some additional warranty package if that's necessary for some projects. So I'm not sure how you guys are familiar with tracker devices. So I wanted to do maybe a little bit of background to give you an overview of the different classes of tracker which are available today in the market. So the first class of tracker which have been initially developed were dual axis tracker. And at HeliosLite, this has actually been our first product. We've designed a dual axis tracker, but for high concentration module where a tracker is required to be able to follow the sun very precisely. But for a regular PV module, the cost of dual axis tracker is basically typically too high. It's very difficult to reach a manufacturing cost which is lower than $30 per kilowatt with a dual axis tracker. So the tracker that we typically see today in large solar farm market are single axis horizontal tracker. And in this market, these trackers are basically being sold for less than 13 cents for megawatt scale project. And so we've been thinking about, can we try to combine actually the benefits of the two technology with a higher energy gain system, which has a gain which is comparable to a dual axis tracker, but at a cost which is very comparable to a single axis tracker. And this is what we've been working on at HeliosLite for the last 2 years. And so as you can see here on this plot, this is the trajectories of the sun during summer and winter season. You see the black line here. Dual axis tracker would follow basically perfectly the sun during both seasons, summer and winter time. And a single axis tracker at a high latitude like that in the south of France, which is basically located at 43 degrees north, is really non-optimum because at noontime, you have basically the tracker which is being flat with a module pointing toward the sky. So you basically have a large angle difference between the position of the sun and the position of the single axis tracker. And it gets even worse during wintertime as the sun is much lower. So typically in the south of France, the sun would be at only 20 degrees in elevation at noon compared to having a tracker basically pointing at 90 degrees, so toward the sky. So with our 1.5 axis tracker, as you can see here, the green line, during the summertime, we can really optimize the trajectory of a tracker to be able to get very close to the ideal trajectory of a dual axis tracker to be able to get extremely good yield. And during wind time, with a reduced inclination angle, we can also get closer to the trajectory of the sun, which means that we can get higher energy output with 1.5 axis tracker. So I'll show you a video to give you an idea of how the system is working. So our 1.5 axis tracker is basically a dual axis tracker, but the two axes are linked together. So we're using only one motor for driving both axes, which gives us an interesting kinetic, and we've patented this kinetic. And as you can see, I'll maybe play again the video so you can see it better. At the end of the day, if you look at the axis of a tracker, you'll see that it's not constant, it's changing during the course of the day. So it's a very different kinetic from compared to a single axis incline tracker, where the rotation axis would stay at a fixed angle. So as you see, at the end of the day, the back of a tracker is getting closer to the ground. So this slide kind of summarizes some of the benefits of this tracker design in terms of the control system, the mechanics, and the basically the actuators. So we've developed very specific support structure, which is also patented to be able to reduce the metal usage. As you can see here, the module are on both sides of the main torque tube, which enable us to have a design which is really optimum for bifacial module, because if we move a little bit the module and include a gap in the center, we have basically no shading on the backside of the module. So the system has been designed to be compatible with regular module and bifacial module, and the same design is compatible with either 60 or 70 cell module. And on each tracker unit, we can put up to 12 module, which gives us about 4 kilowatts of installed power per tracker. And so thanks to the special kinetic of this 1.5 axis tracker, we can get higher energy gain, and I'll show you some result on some pilot project. The structure is very lightweight. It's actually lighter than the module that it supports. And the design is extremely modular. I'll cover this in further details to give you an example of how this can be used to improve your basically layout for a complex field. And the latest version of our system is now equipped with a self-powered control system. So it includes a lithium-ion battery pack. And basically the system doesn't need to be connected to any AC main or anything. It's basically charging automatically, taking a little bit of current from the module. And the system is extremely simple to set up. We've developed an interface with a Wi-Fi connection. So any devices like a portable computer or a cell phone can be used to set up the system. And we've done wind tunnel test, pre-certification of system resistance according to Eurocode, using the services of the APAV, which is basically a control bureau in France. And we're starting also to do dynamic measurement of load on the tracker, and we've included a 3D accelerator inside the control system to be able to measure the torsion of the tracker main beam. And this is really important for tracker, and there's been some publication recently for single axis tracker regarding this type of issues, because with very high aspect ratio tracker system, you can basically have some torsional instabilities issues. Hopefully, thanks to the design that we have here, we have very short beam, so this tracker design is not susceptible to this type of issues. For the actuation, we're using very robust linear actuator, which are completely sealed. And one of the advantages of this type of motors is that they're extremely easy to replace, because you only need to remove 2 bolts to be able to change the actuator. So this really, the system has been designed to really reduce OM time, and if you have an issue, it's very easy to fix it. And multiple foundations are available. I'll talk a little bit about that because the system has been designed to spread the mechanical load. So we don't necessarily need to use pile driving equipment, but we can use either small ballast or ground anchors for the foundation options. So we'll go to the second poll question now.
Yes. So we'd just like to take another quick poll here. How much more energy can a 1.5 axis PV tracker capture versus fixed racks per annum? Okay, well, here we have the poll. I think there's only 12% say 5 to 10%. I think that's, most people would think that's down on really where single axis trackers can be. 10 to 20%, I think, is where a lot of people are now experiencing real world single axis tracker performance at 10 to 20%. But it's interesting, I like this, 36% say they're very optimistic about a 20 to 30% gain, and 18% believe that, and I'm assuming this is with high performance modules, the gains could be more than 30%.
Okay, so that's actually a very tricky question, because it highly depends on the site latitude and the quality of the irradiance. So let me just give you an example here of a pilot project that we've installed in May 2017 with Enerwhere. So this system comprises 2 trackers, and on this installation we've recorded an annual average energy gain of 31% versus, in this case, an east-west oriented fixed system. A south phase system at this latitude would have produced almost the same amount of energy because we're at a south latitude, which is just about 20 degrees north. And the availability of the system has been 100%, so we've been very pleased with the system overall performance. And the total energy sum up to 2200, little bit more than 2200 kilowatt hour per kilowatt peak. So this is a fairly good site in terms of irradiance. One of the advantage that our partner Enerwhere really likes for his application is the fact that with this system, not only we can get a high energy gain during the year, but particularly we can get a higher energy gain during winter season. And for sites which are not necessarily grid connected, this can be a really interesting advantage because if you're trying to produce the same amount of energy during the year, if you have high energy gain during summertime, it might not be very useful for this type of application, but having a higher energy gain during winter time enable you to reduce your seasonal variability. And it's quite significant because compared to a single axis tracker, which would reduce the seasonal variability by only a few percent, our tracker here did actually cut down seasonal variation by 40% compared to a fixed installation. So this is interesting, and this is the type of application where we think our system is really pertinent. Other side benefit of the system, which come really from its mechanical design, is the fact that it can be easily installed on uneven site, which has been typically an issue for single axis tracker. If you have a single regular slope, you can easily tilt the main beam of a single axis tracker and go up to 10-15% slope. But as soon as you have some variation, it becomes very difficult with very long single axis tracker. Where with our 1.5 axis tracker, since the units are very small, we can easily cope with the slope of the site and we don't need to do some leveling. So this is a very interesting advantage because, of course, civil work can get very expensive when you have to do a lot of leveling to be able to planarize the field. We've developed an installation technique also to be able to install all the module with a tracker in a flat horizontal position, and you can see here some picture on the bottom left of this slide, where basically more or less the height of a person, a worker, can easily slide the module above a tracker structure. And when the system is installed and we've done all the cabling, it's very easy to tilt the tracker into its final position. All the parts of the tracker are very lightweight. We've designed the structure with parts which weigh no more than 25 kilograms. So workers can easily install the system by hand without having to use lifting equipment. And as I mentioned before, for the foundation, since we have a very specific chassis structure and a pole which basically spread the load and contact onto multiple points on the ground, we can use small anchors to be able to stabilize the system. So we don't necessarily need pile driving equipment, which is an interesting also aspect for small or medium-sized project, because bringing the pile driving equipment can be difficult, and the ground anchor can be driven to the ground with just a jackhammer. In terms of overall metal structure weight per kilogram ratio, the design is very comparable to leading single-axis tracker. So the structure is very cost-effective from a metal design standpoint. Let me give you also an overview of what we can do on complex site. If you have a site like that, which is a former landfill, where you have a lot of obstruction, where because of gas venting holes, it's very difficult to do a compact layout with a single-axis tracker, even if you have independent row control. As you can see here for this site example, we're starting with a fairly high ground coverage ratio locally on the single-axis tracker at 42%. But when you try to fill a parcel, you end up with a lot of gap. With our 1.5 axis tracker, we start with a lower ground coverage ratio of 34%. But when we're done actually doing the layout for this field, we have actually a slightly more installed capacity compared to a single axis tracker. And of course, because of a higher energy gain on the same actually land area, here we're actually producing more energy per year. So of course, this is an extreme case example. If you have a very flat land with a rectangular parcel, you'll be able to achieve higher packing density with a single axis tracker. But as soon as you start to have obstacle or a parcel which is not square, then you have a lot of border loss issues, and our tracker can be actually then useful for this type of sites. So with this tracker, as we're starting with a very small unit site, we can basically target many applications, and we think this is where our system really add value, because single axis tracker has been really designed and optimized for very large solar farm, basically starting above 10 megawatt now for the leader supplier of single axis tracker, where with this system we can start at only 10 kilowatt scale project, and we can use this technology for isolated site, for farms, small businesses, pumping application, and Daniel will cover more of industrial application with this tracker technology. And the structure has been designed to be really simple to install, so you don't need complex equipment, large equipment to be able to do the installation, and everything can be done by hand. So this is really an interesting advantage, which makes actually this technology accessible for smaller size project. And of course, the main advantage of this technology is that it gives you a higher energy gain compared to other tracker systems. And as I briefly mentioned, the reduced seasonal variation, the fact that the tracker curves is better matched to basically the consumption of an industrial user are other advantages, and Daniel will cover those type of advantages for his applications. Okay. So it's all yours, Daniel.
Wonderful, thank you, Etienne. Yeah, so let me briefly introduce Enerwhere, because I think that's relevant to see how we use this tracker. Enerwhere is really a distributed solar utility company. And what this means is that we supply electricity and cooling as a service to commercial and industrial customers that don't have a grid connection to what is typically a government-run grid. We do this across the Middle East and Africa, from offices and hubs in Dubai, Abu Dhabi, and in northern Nigeria. And what's maybe unique to our approach to this is that we supply a lot of temporary power with solar diesel hybrid plants, where we can deploy equipment in a few days. We leave it at the location where the client requires power for short time periods, as short as 6 months, typically 3 to 5 years. And then we're able to redeploy the equipment to another site and continue to use it, even if the client gets a grid connection, which would be cheaper than a solar diesel hybrid plant, or if their power requirement disappears. This could be the case for construction companies where the project finishes, or for a mine where the ore body is used up and the mine closes. So basically, we're not necessarily, I mean, it's not the same as the standard in the solar industry where you deploy and you leave stuff in place for 20 years. We can do shorter contracts, and we do, and that means we play across a number of areas that are unusual for the solar industry: space constraint, short deployment time frames, and of course, mostly isolated sites where there's a constant need to match up the power supply with the power demand. The solar industry, historically speaking, has ignored this, right? It's always been the utility company's problem, and the solar guys produce whenever the sun shines, and most tariff structures are per kilowatt hour tariffs on an annual basis. They don't truly differentiate between the moment of when the production is, but this does matter to us. We've won a whole bunch of awards for this. I won't go into the details. But if we could go to the next slide, Etienne, I think you have control here. Thank you. Right, that means we supply to a number of customer segments, as I mentioned, typically on a power purchase agreement, but as a full utility player, day and night power. The most common one is actually staff accommodation camps for construction or oil and gas. On the construction sites themselves, for offices, for cranes, for pumps. The oil and gas industry is a very specific application. Drilling rigs, for example, use several megawatts of power. It's an industrial application, but one where mobility is important. A drilling rig stays in place for anywhere between 3 weeks and 3 months and then moves to the next location. Manufacturing is a big application here in the Middle East. Surprisingly, not all factories have a grid connection. And again, they're matching up the power supply with the demand is crucial to improve, to increase the solar share in the power supply. Hospitality, we've serviced multiple island sites, hotel islands. Obviously, a lot of people know the Maldives, where every resort is on an island. But these kind of load curves are common throughout the world. Mining is a popular topic recently in the press, even though surprisingly few people have actually installed projects, because the argument typically goes that solar can just not produce enough power or supply a large enough share, because there's simply a fixed maximum load, and going with a fixed tilt plant to that maximum load can supply between 15 and 20% maximum of the total 24-hour power requirement. And when you take seasonal variation into account, the share of annual energy supplied by solar is typically even lower. So a lot of the mining guys, while in theory they're interested, in practice haven't really bothered much because the impact is too small. There are, of course, ways around this, namely batteries. I can throw batteries at the problem, and this is what's happened recently with the fall in battery prices. That's getting easier. But nevertheless, batteries are 2 to 3 times the cost of the solar equipment, relatively speaking. So in fact, my solar power at night is roughly 4 times as expensive as during the day. So we would like to do everything in our power to increase the share of solar that can be used directly. And this is exactly what the HeliosLite tracker allows us to do, right? It basically increases the part under the load curve that we can supply directly. It reduces potentially for the same kilowatt hours the peak power requirement, thereby reduces the AC components, it reduces the inverter sizing, and thereby dramatically reduces the levelized cost of energy. What we have here is a real load curve. This is a case study of what is effectively a mining plant. It's a concrete crushing plant, a concrete recycling plant that has some variability, right? These guys obviously have to maintain their machinery. They run for a while, but what you can see is a classic case of any industrial load. Basically, whenever they switch on, they come on full load. They run that load for a period of time, and then they switch off. You see in this graph the actual solar production on site. Keep in mind that this is a site without battery storage. So that means in the mornings and in the late afternoons, we're running currently between 20 and 30% solar share instantaneously, which is already quite high for an industrial plant where you have to have heavy machinery. We have high variability in the instantaneous power requirement. So without batteries, there isn't that much more we can do without experiencing grid stability issues. If I want to increase the solar share now, number one, I obviously need batteries from a grid stabilization point of view. But even if I just ramp up the normal fixed tilt plant, I will continue to see a pattern where I just don't produce enough power in the mornings and the evenings. The only way to do so would be to oversize the PV plant dramatically, thereby either giving up production at noon, where I have to curtail, or dramatically increasing the size of the battery. And this is the application that Etienne mentioned earlier, where the unique ability of the HeliosLite tracker is twofold. Number one, the additional production in the morning and the evening helps by reducing the battery requirement. And secondly, the load in this particular case is the same in summer and in winter, even though in the fixed tilt PV production would be only about 60% in winter compared to the summer. So again, when I look at an annual basis, I can use the tracker to dramatically increase the solar penetration, which in an environment where my kilowatt hour from a diesel generator costs me anywhere between 15 and 20 cents, right? That every extra kilowatt hour that I can supply from solar is a dramatic help on the overall economics of the plant, right? And this is really where this tracker shines. There are obviously some other markets where the requirements are different, but with this tracker you can change the tilt angle to whatever you like, and you can thereby match your production with the demand requirement. And that's of course crucial in off-grid sites where the grid is very small. But in our view, this will also become more and more important in grid connected sites, because as the solar penetration on any grid rises, the next marginal kilowatt hour in summer at noon becomes pretty cheap, right? The value of the next kilowatt hour at noon, even in large grids, the German grid, for example, regularly in summer runs on 100% renewables now. And if you keep adding conventional fixed tilt solar, you'll just produce more at a time when nobody really needs it. And that will be reflected in tariff mechanisms and in auction mechanisms sooner or later. Abu Dhabi, for example, in their recent auction for a 1.2 gigawatt plant, actually introduced a different tariffs for summer and winter. While this one was the other way around, right? They pay more in summer than in winter. As the solar penetration increases, yeah, this will be adjusted by multiple jurisdictions. Anyway, so we like this tracker. We've installed the first pilot units here. We have a few hundred kilowatts more under installation and a few more megawatt in the pipeline. Yeah, we think it will substantially improve matching between supply and demand in our grids. Thank you, and back to Etienne.
Okay, thanks a lot very much, Daniel, for this very nice presentation on your application and really the benefits of what we can actually bring with this tracker technology for your application. That's very interesting. And of course, to complete this presentation, we also obviously need to talk about levelized cost of energy. And this is where, of course, trackers are very useful, and we need to present you a case study where we've done a very simple levelized cost of energy analysis here. So this would be for a project in the Emirates, where you can see the yield that I've actually taken for this example with 1.5 axis. We would get close to 2,300 kilowatt hour per year with our tracker, which would represent in this case a gain of 30%, which is very comparable to the gain that we've measured on the pilot project at Murai Island. And for the same site location, if you use a single axis tracker, you would get about 20%. So if you actually put then numbers behind that to run an LCOE model, and you compare the cost of energy that you get against a fixed rack structure, I've actually taken 4 cents per watt peak for the cost of a fixed rack structure. You see that with a single axis tracker, you would need to get the cost of a tracker below around 14 cents to be able to have a lower levelized cost of energy compared to a fixed rack structure. And typically, single axis tracker get to around 11 cents these days for large scale project, which bring you an LCOE benefit in this case of around 3.4%. But if you take our 1.5 axis tracker on the same site here with an energy gain of 30%, at the same tracker cost here, you would get a lower LCOE by almost 11%. So that's a fairly significant advantage. And all the other costs, financial, depreciation rate, and lifetime of the plant have been kept constant to make this simulation case as simple as possible. And right now, HeliosLite is working with manufacturing partner, which give us good ability to get in this range of 11 to 13 cents, which is where most of the single axis tracker are today in the market. So we'll go to the last poll question of this webinar.
Yes, so if we can take a poll here, what would you consider as the 2 most attractive aspects of HeliosLite's 1.5 axis PV tracker? We have higher daily energy output and seasonality stability, quick and easy installation, scalable solution for multi-kilowatt peak to utility scale, adaptability for difficult terrains, and the potential to reduce a project's LCOE. Right, well, the poll's in. I think this is a very interesting result here, with 66% saying it's the higher daily energy output and seasonal stability. I think this is a very key aspect here of the technology. Quick and easy installation. We're talking single units. I think that's very important. That's 27%. Scalable solution for the utility scale from kilowatt peak at 14%. At 32%, we're talking about the adaptability for difficult terrains. I think actually, I think the issues there are very, very important, and its capabilities there. And the potential to reduce a project's LCOE comes in sort of second place there at 63%.
Okay, thanks a lot, Mark. So where do we stand today in terms of technology development? So as I mentioned, we started this product development about 2 years ago. We've done our first initiation of a pilot system in June 2016 with this 1.5 axis tracker. Our first model was equipped with 10 modules of 60 cells. And we've since then increased the tracker size to be able to mount now 12 modules of 72 cell format, either standard module or bifacial module. And so we've completed wind tunnel tests. We've done the static load verification. We've done accelerated aging test on mainly the linear actuator, but also the rotation points of the tracker. And we've done this both in the lab with basically extreme load on the linear actuator, which are designed to be able to lift up to 800 kilograms of force dynamically. And in the field, we've done also accelerated aging test and simulating 100 cycles per day, which in 3 months' time gave us already 25 years. And we've run this test during 6 months, which gives us basically a lifetime of 50 years, which have been completed with this accelerated aging time. And we haven't really seen any systematic degradation of the linear actuator. So we're very confident that this actuator will actually do the job for a project. And so far, all the field results that we've been getting on this actuator have been extremely good. And as I mentioned, we've recently completed pre-certification of the tracker structure according to Eurocodes with APAV. And we're in process now of deploying our first larger scale project, initially with Enerwhere, which is one of our early basically technology adopter clients. And so as you mentioned, we have already 54 trackers which have been shipped to Enerwhere, and there are actually other orders which are coming for a larger scale project. And we're in process of putting in place now a partnership to be able to ramp up production in 2019. So before I conclude this webinar, I'd like to give you a quick overview of an interesting project that we've recently completed with European Energy. This is a new test site that we are doing at the Danish Technical University to be able to compare different tracker technology and normal module versus bifacial module. So in this test field, we've installed 2 tracker units. One unit on the left is equipped with bifacial module, and the unit on the right is equipped with regular module. And so this is going to be very interesting because on this side, we'll be able to compare the performance of these 2 module technology, and we'll be able to compare the performance of our 1.5 axis tracker with a normal single axis tracker and fixed table. So we're really looking forward to seeing the result from this test site. And this site is located at a fairly high latitude. So this is also another example where 1.5 axis tracker can be really beneficial because of the incline axis, where the single axis during wind time will produce very, very small gain, if not actually probably negative compared to fixed table, because the module are not inclined towards south. So currently we have about 800 kilowatts of tracking system being monitored by HeliosLite. We've deployed system in 10 different countries. So we have several in Europe, North Africa, in Senegal and Morocco. In the Emirates, we've deployed several systems with Daniel and Enerwhere. We have also a partner in India. Japan was just for dual axis tracker, but we think this could be a very interesting country, also target country for 1.5 axis tracker because of land constraint. It's very difficult to find flat land in Japan, so our 1.5 axis tracker could be very interesting. In France, we actually are doing this autumn an installation on a site which is located in a mountain location where the tracker will be installed on a very extreme slope of 50%. So this basically open new market application for tracker. In the following two countries, in Australia and South Africa, we're starting to put in place agreement with some distribution partner because for those countries, there are a lot of isolated sites and our system can be very useful for pumping and isolated site application where the system is very simple to transport and can be installed without any concrete. So this is very interesting for very isolated site. And for pumping application, if you can use a tracker with the same size pump, you're able every day to pump more water. So the total capex of your system is actually reduced if you're using a tracker compared to having a larger PV installation with a larger oversized inverter. So this is a very interesting also application case. So as I mentioned before, we're just now initiating discussion with different world-class manufacturing partner in order to be able to scale up production and be ready to deliver megawatt scale project in 2019. So of course, would like to add as a next step your project to this map. And I'd like to thank you very much for your attention and attending this seminar. So we'll go on to the last part of the webinar, which is the Q&A questions.
Well, thank you very much, Dr. Menard. We've actually had some very good questions come in already, and one or two here are very consistent, asking very similar things. So I'll try and sum up one or two here for you, for both of you to take a look at. What is the first question really comes up is what are the best markets for the 1.5 single axis? In particular, people were asking particular locations. For instance, is this technology recommended for low longitude locations? So, pretty much equator or 20 to 10 degree areas, such as, say, for instance, Brazil.
Yeah, that's a very good question. Thanks, Mark. So we are today working with early technology adopters like Enerwhere and Europe Energy, who are actually looking at cutting-edge technology in order to be able to really improve their competitiveness in their markets. So we think, yeah, our tracker could be very, very attractive for also, solar communities and all the project where you basically, as Daniel explained, where you need to match basically production to the power curves of your customer. This is where we think that our tracker really brings a lot of benefits. If you are closer to the equator at locations which are below 20 degrees of latitude, then the difference of energy gain that we bring compared to a single axis tracker is not very large. So we think that the target market will be mostly for sites which are further away from the equators. And of course, if you have any application that require battery, adding 1.5 axis tracker, as Daniel explained, can we cut down on the your capex expensive for the most expensive part of the system, which are the batteries. So if you're able to reduce your battery size by only maybe 10%, you'll actually pay very easily the extra cost of the tracker.
Okay, I'm collating another group here to do with the actual tracker system itself. I'll start with an aspect here about the wind issues. So what are the maximum limits that it can take? What's the impact from a torsional perspective? And is there really a limit to that kind of restrictions from extreme weather conditions?
Yeah, that's a very good question. Today, the system has been designed following Eurocode recommendation. And so we've completed wind tunnel tests to be able to get the drag coefficient of the system. And from that, following Eurocode specification, we're able to withstand a maximum gust wind speed of 175 kilometers per hour. And when the wind is higher than an average speed of 50 kilometers per hour, the tracker automatically go into a stop position. And so this is the position where we have a minimum drag coefficient. And in this position, the tracker is able to withstand this 175 kilometers per hour. And we are looking also at the possibility for market where you're closer to the equator at our site, where you have actually higher wind load requirement to basically have a second variant that would be inclined at a lower inclination angle, like for example 5 or 10 degree, which would induce a significant reduction of the drag coefficient. And with this configuration, we would be able to withstand higher wind load using the exact same structure, just one change of the parameter. Of course, the structure could also be reinforced, but first would like to concentrate our application where the wind requirements are not higher than 175, which covers already a lot of markets. And in terms of the torsional instability, so that's, I would say, one of the main advantages of this 1.5 axis track compared to single axis tracker is the fact that the main beam is very short compared to a single axis tracker, which has very, very high aspect ratio. And when you have a very high aspect ratio structure, you can have some instability in torsion, which is not the case when you have a lower aspect ratio structure. So I think that could be a very key benefit also of this tracker in terms of stability under windows.
Another common group of questions coming in relates to how the algorithms work, and in particular, I think the understanding of shading as well as the backtracking side of this. Can you? Well, we've got very short time, but just maybe a quick mention on that.
Yeah, absolutely. So the system, the control system is equipped here with backtracking algorithm. So at the beginning and end of the day, instead of tilting the module completely toward the sun, we start with a panel in a flat horizontal position. And as the sun rises in the sky in elevation, the tracker starts actually to incline the module toward the sky. So this is a very common technique for single axis tracker. To be able to avoid cross shading between the tracker unit, because what you really want to avoid is direct shading, partial shading on module, because it's actually quite bad for actually the module. So this is a typical, very typical backtracking algorithm that we're using to be able to minimize cross shading during the basically sunset and sunrise time. And of course, the parameters are configurable. So depending on the site position, the amount of backtracking is automatically calculated. And it's also a function, of course, of the size of the module and the spacing that you specify between the tracker. And the control system then automatically calculates the optimum backtracking angle for each tracker unit.
One of the, some interesting questions as well here, what is the optimum DCAC ratio for a 1.5 axis tracker?
Yeah, it's a good question. Yeah, for normal fixed rack PV plant, developers have had the tendency to, of course, oversize slightly the DC side, because it's very rare that you're actually producing at the peak rated capacity of the system. So with tracker, we typically recommend doing a 1-to-1 ratio. So if you have basically 1 megawatt field of PV, I would recommend that you do actually also 1 megawatt inverter and no undersizing of the inverter.
Hi, this is Daniel. Maybe a good point to jump in there. I think this does depend on the cost of energy, the cost of foundations, and the duration of the contract and your cost of capital. So it's a little bit more complex. We typically in our projects oversize on a fixed tilt rack by at least 30 to 40% DC to AC. And given that we have a much higher starting point, we still oversizing DC to AC, even including the trackers. I just think that it's not just a technical discussion. This is very much linked to specific economics, and I think is a case-by-case analysis.
That's understood. Thank you. Well, we were going back on the backtracking side, but actually a question, good couple of questions regarding from an analysis point of view of the right tracker, what version of PV Assist would be used for supporting this type of technology?
So right now, obviously, PVSys is not able to simulate exactly our tracker because we have a very specific kinetic, which is very unique to a HeliosLite tracker. So what we often do when we use standard simulation package like PVSys or Solar Advisor model is we run a parametric simulation where we change the inclination angle of a single axis inclined tracker from here for the current variant of our tracker 17 degrees down to a few degrees, and then we take the output of all those parametric simulation to be able to find the one at each time hour which match as best as possible our tracker position, and we combine all the results to then get the output of tracker. So this is the simplest way to use a standard simulation package to be able to simulate our tracker. Of course, internally, we've developed also our own simulation package, which enable us to put the exact trajectory of the tracker in order to compute energy yield. So we're able to do that. So if you have project, don't hesitate to send us your requirement and we'll be able to do simulations for you.
A couple of more questions regarding the system itself coming through. What are the snow loading limits, and how does it stow away during a snow event?
Yeah, it's a good question. In France, we're actually located near the Alps, and we actually often have winter snow during winter time. And what we found is that when the panel inclination angle is above 30 degrees, which we easily reach here because at the beginning and end of the day, the tracking limit of the tracker is 46 degrees, the snow basically doesn't really stick anymore on the tracker. So as soon as we have more than a couple centimeters of snow, it basically gets actually flushed during either the morning or evening time. And if we have very, very heavy snow storm, we can easily do additional cycle during the day to be able to dump the snow on the ground. So we actually haven't taken snow load into account because we've actually never seen accumulation of snow on the tracker. But we plan to do some installation at a high altitude site to really demonstrate this with a practical pilot project to be able to show that this could also open new market where fixed panel are actually difficult to install in high altitude for high altitude sites.
Yeah, collating a couple of other questions here. We're jumping back a little bit to the type of fixing systems, for the trackers themselves. I'm assuming from the presentation there are various ways in which the actual tracker is located. Perhaps give people some ideas of it's dependent on the terrain.
Yeah, I'm not sure if your question is about the foundation then, what foundation we would be using?
Yes, the foundation, sorry, yes.
Yeah, the foundation. So yeah, there are, as I mentioned, multiple options. So you can see here on this picture, for this client, they wanted to use the concrete. So we've actually used some small concrete slab. There's actually nothing under the ground here. The slab are actually very thin and just above the ground. But the solution that we most of the time recommend are ground anchors, because you can easily adjust the size of the anchor depending on the soil condition. And what we really like with this solution is that when you drive the anchors into the ground using either a jackhammer or small, basically hydraulic bulldozer, which is equipped with a jackhammer head, you can actually drive a hammer at different depth very easily and adjust the size of the hammer depending on the soil bearing capacity. So if you are in a very hard soil, you can use a smaller anchors, and if you're a very loose soil like we've done at Murai Island, which is basically sand directly on the beach, you can use larger anchors. So it's very easy to adapt the solution to the soil condition, and for isolated site, you only need a small jackhammer to be able to drive the anchor into the ground. So it's a very interesting solution from that standpoint. And when you actually pull on the anchor to pivot the head of the anchor into the ground, you actually measure the amount of force that you're able to take on each anchor. So that's the other aspect that we like with this solution, is that you're basically testing every single anchor that you're driving into the ground, which gives you confidence that you'll be able actually to take the load that they're actually designed to withstand. Where if you're actually doing pile driving, often for a large site, you're only doing screening with and testing few piles on a large site and hoping that the soil condition will not vary across. And so sometimes this can be an issue. We've seen some issues with pile on site where you have complex soil condition, because you basically rely only on friction to avoid the pile from going off. Where with the anchor, you really have a head which is buried into the ground, so you don't really rely on friction with this solution. But of course, the pile can be used as an anchor, as a solution, and you can also use ground screws, but we found that they tend to be more expensive than the small anchors and more difficult to install.
Right, well, looking at the time, we're very close to the end. Quite a few people have asked as well. I mean, where do we go from here, as in getting more information from you about the technology?
Okay, so you get our contact information at the bottom of the slide, info@helioslite.com. And for all the people who have accepted that we can contact us, we'll be sending an email with basically some questions to ask you which application you actually like to consider for basically your need for your application, and see how we can actually help you with your application with this tracker technology.
And we will be doing the same with the presentation side. Make the slides available, and that will be notified in emails to everybody that registered. So, well, once again, gentlemen, thank you very much for joining us and giving us such an insight into the 1.5 axis tracker system. And thank you, everybody, for joining the webinar. I hope, like me, I found this very, very interesting. Thank you very much.
Thank you very much. Bye-bye.